explain high resistance or rheostatic arc interruption method in circuit breaker. So in this method, the arc is controlled such that there is an increase in the resistance, that is arc resistance, with the increase in time. The method itself suggests that it is high resistance arc interruption. So the value of current decreases with increase in the value of current to such a low value that the arc cannot persist and the arc is extinguished or the arc is interrupted. In the AC circuit breakers, the arc voltage and arc current are in phase because the nature of the arc is purely resistive. So the arc voltage and current both are in phase. So when the arc current becomes zero, the voltage across the contacts of the breaker is almost zero. This is called the restriking voltage. So the possibility of restriking of the arc becomes very less, but the energy dissipating in the arc is very high. This method is used in low and medium power AC and DC circuit breakers. So to increase the value of the arc resistance, this can be done by four ways. One is by increasing the length of the arc. So the resistance of the arc is increased by increasing the length of the arc because R is directly proportional to L. So when the length of the arc increases, the resistance naturally increases with the length increment. Now by cooling the arc, so when the arc cools, the voltage required to continue the ionization is more, because as and when we are cooling it, we are giving the deionization or we are processing the deionization. So the arc may be quenched fast. So the cooling of the arc increases the effective resistance. By splitting the arc, so good amount of voltage is absorbed on the two contacts of the circuit breaker, means the moving and fixed contacts of the circuit breaker. So if the main arc is split into the number of small arcs, that is we are cutting down the main arc into small number of chunks, the voltage is absorbed on each splitter and there is decrease in the voltage. Now the last method is by decreasing the cross-sectional area of the arc. If the cross-sectional area of the arc is decreased, the voltage required to continue the arc is increased. That means the resistance of the arc increases. So to decrease the cross-sectional area of the arc, arrangement is made to pass the arc through the narrow space or contacts to reduce the cross-sectional area of the arc. So this is how the high resistance or rheostatic arc interruption method works in the circuit breaker.